going to be using the following equipment. The first thing which we'll be using for the experiment will be a barometer, which is used to know the atmospheric pressure. The second thing which we'll be using is a thermometer, which we utilize to know the temperature of the water in the equipment. As for the equipment, the first thing which we look into is on the right side, which is called a flow meter. It is utilized to know the total amount of flow traveling through the different pipes. The units for this will be liters per hour. We have a double pressure gauge, which is utilized to know the pressure difference between the two pipes, whether it is a major loss in such cases or in the minor loss such as elbows and knees. So before we start the experiment, there are certain things which we need to look into, starting from the various precautions. The first precaution which we need to look into is the pump is fully submerged in the water, so whenever it is working on, as soon as it turns on, it is never empty. In that case, it might damage the pump. The second thing which we look into is the calibration of the equipment. Both the double pressure gauge should be equal when the flow reading is 0 right here. The both levels right now, as we can see, is almost 88.7, which is totally fine with us. So we are going to be taking 5 different readings for the major loss, which is the pipe, and then we're going to be taking 5 more readings for elbows and knees, which are these pipes, for knowing the minor loss as well. So let's start the experiment. So the last precaution which we need to look into, that there is no air bubbles in these rubber pipes, because if there are any air bubbles, it's going to give a false reading. So the first readings which we are going to do is we're going to take the major head losses in the falling pipe. We have already connected the 2 rubber ends of the pipes from the meter into 2 corners, and we can see both of them are exactly stable right now. Now we are going to start increasing the flow. We'll give an equal increment to get a total number of 5 to 6 readings, which can be utilized for our calculations. So I'm going to start with a flow of 300. We need to make sure our eyes are directly perpendicular in order to know the exact readings, and there is no parallax error. So when the flow is exactly 300 readings, we can see from the 2 meters right here, the left reading is 87, and on the right side it is 88.5 at a flow rate of 300 liters per hour. As we said before, now I'm going to increment the flow rate to know the difference it causes in the major head loss. So I will increment it by 200 by turning this valve to the left side. At 500, the readings are 88.5 and 88.8, 85.5 and 88.8. At a full. We increment it again by 200, taking the flow rate to overall 700 liters per hour, and we take the readings again. On the left side, it's 83.4. On the right side, it's 89.4. Another increment of 200. We'll have to wait a bit in order for the bubbles which are being formed in the rotometer to settle down. They are settled down right now. On the left side reading is 80.6. The right side reading is 90. We're going to give it another increment of 200 liters per hour. That takes the total to 1100 liters per hour. If you look at the readings on the left side, they are 77.5 to 90.6. Finally, we'll just take an initial reading in case there's an issue. So at a flow rate of 1300, we have to wait it so there's no communication in the system. So at 1300, the readings are 73.8 and 91.2. This sums up the total readings which we need to take for the major head loss in the following pipe. The next part of the experiment is going to be noting down the minor head loss, which is going to be the knees or the elbows.
As my friend illustrated how can you measure the major losses, now I will demonstrate how will you measure the minor losses. So we have either two alternatives. I either measure the minor losses through elbows or knees. And we will show you a demonstration of how to do it on elbows. So we'll first close this to prevent any water from passing. Then we'll connect this. Now since they are connected, we will make sure again that there are no bubbles so it wouldn't affect our readings. Now we will have to open the switch so it will pass, so the water will pass here. And now again we'll start adjusting all the flows and measure. Again, another precaution, we need to make sure that the water levels are the same in the two bar gauge. Now we'll choose an increment of, we'll start with 200 meters. Then we'll do pressure, we go measure the pressure. Here it's 87.9 and 88.8. Again, we'll do 5 readings. So we'll increment it by 200. And then we'll make sure that the head of it is at the label. Now we measure the pressure. 86 and 89.4. Again, we readjust the flow to 600. We need to make sure that the increments are of the same magnitude. Again, we make sure that the head is at the label. Now, the left side is 84.3, and the other one is 90.2. Again, we'll increment it by another 200. Now it's 81.9, 91.5. So better than if we measure. And for the final reading, make sure that the bubbles are gone. Then we'll read it again. Left side will be 77.7. The other one will be 92.9. And this will be, and then we'll add one more as a precaution if there are any outliers in our measurement. Again, we'll make sure that the bubbles are until the bubbles go away. The pressure difference in this time will be 73.5, 94.5. And this will conclude our demonstration. And for another demonstration, but we'll not show it, we'll change the tubes and we'll adjust them here to measure the minor head losses in the elbows. And finally, one more thing. Finally, there are more readings that needs to be taken for the experiment to be completed. So the first thing is, for measuring the minor losses, we need the elevation. So we will measure it using a ruler, and then it will be given to you in the lab measurements. And for the temperature, we need the temperature of the water. So we'll just put it and wait for it until it reaches equilibrium. It will be around 27 degrees Celsius. Finally, it was asked that we should measure the atmospheric pressure of the room, and by reading and looking perpendicular, it's 997 millibar. And this will be the conclusion for our experiment.